Determination of field density by sand replacement method. So these are the things that we will be needing for the test: cylindrical calibrating container, sand pouring cylinder, metal tray with a hole. There are three stages in which we are conducting this. So determination of weight of sand filling the con, then determination of bulk unit weight of the sand, and determination of bulk unit weight of natural sand. So determination of weight of sand filling the con. Uh, for that, sand passing through 600 micron sieve and retain over 300 micron sieve is used. Pouring cylinder attached over pouring con is placed over level ground and completely filled with sand and weight. Weight of the sand plus cylinder before pouring will be W1. Then now place the cylinder on the glass plate and open the shutter. Allow the sand to run out. Weigh the sand collected on the glass plate. This is the weight of sand filling pouring con. So this is the pouring cylinder in which we have we have explained about the shutter. So this is the shutter in which we will open it, and there's a glass plate in which we will open it, and the sand will enter to this con. So weight of sand plus cylinder before pouring will be W1. Weight of sand in pouring con will be W con. So weight of sand plus cylinder after pouring on the glass equal to W2. So we can calculate the W con will be W1 minus W2. So determination of bulk unit weight of sand. So determine the volume of calibrator container. Fill the pouring cylinder with weight W1 again. Now placed our calibrating container and open the shutter. Permit the sand to run into the calibrating cylinder. When no further movement of sand is seen, close the shutter. Remove the pouring cylinder and weigh it. So this is the pouring cylinder in which there's a shutter. So if we open it, there will be this weight of a cylinder plus this weight of con. So weight of sand plus cylinder after pouring into calibrated cylinder will be W3, and weight of sand filling calibrated cylinder will be W1 minus W con plus W3. So bulk unit weight equal to weight by volume. So determination of bulk unit weight of natural soil. So before that, we have to clear the soil surface. Exposed about 450 mm square area of the soil and trim it down to level surface. Then keep the metal tray on the level surface and excavate a circular hole of 10 centimeter diameter and 15 centimeter depth. Excavate the soil through the central hole of the tray using the hole in the tray pattern. The depth of the excavated hole should be about 150 mm. Collect all the excavated soil in a metal container and determine the mass of the soil. Remove the metal tray from the excavated hole. Put excavated soil into a container. Then we have to weigh the soil. Fill the sand pouring cylinder within 10 mm of its top. Determine its mass, that is M1. Place the cylinder directly over the excavated hole. Allow the sand to run out the cylinder by opening the shutter. Close the shutter when the hole is completely filled and no further movement of sand is observed. So this is a figure in which placing sand, fill cylinder on the hole, and we are opening the shutter to fill the hole with sand. So remove the cylinder from the filled hole, determine the mass of the cylinder, and it is M4. Take a representative sample of the excavated soil, determine its water content. Take soil sample to excavate moisture content of the soil. So in order to determine the dry density, mass of excavated soil is M1, mass of pouring cylinder filled with sand will be M1, mass of pouring cylinder after pouring into the hole and con will be M4, then mass of sand in the hole will be M1 minus M4 minus M3. So this is the mass of sand in hole, M1 minus M4 minus M3, that is the mass of con. So we know volume of sand in hole equal to weight of sand filling the hole by gamma sand. Then volume of sand in hole will be equal to volume of soil excavated from the hole. So from that we can calculate it. So gamma equal to W into gamma sand divided by weight of hole. So this is the equation. So gamma D we can calculate by gamma by 1 plus W. W is the water content, gamma is the moisture unit weight, and gamma D is the dry density. So determination of unit by weight by co-cutter method. So we have rammer, dolly and co-cutter. So the steel dolly is then placed over the cutter to prevent the damage to the edges of the co-cutter. The cylinder is then embedded into the ground up to its full height with the help of rammer and is taken out by excavating its sides without disturbing the sample. The surplus soil at both the ends is trimmed and the weight of the cylinder with soil is determined. Then from the non-dimension of the cutter, the volume of the soil is determined. So weight of cutter plus moist soil equal to W2. Weight of moist soil equal to W2 minus W1. W1 is the weight of cutter. So volume of cutter is equal to pi by 4 d square H. So bulk unit weight by volume, and dry unit weight gamma by 1 plus W.